This is the green sea turtle, scientific name Coloniomytis. They live in tropical and subtropical oceans worldwide. Adults usually stay in shallow coastal habitats like seagrass beds and reefs, while hatchlings spend their early years drifting in the open ocean. They aren't strongly social, but they often gather at good feeding areas and form large groups offshore during nesting season. The green sea turtle's umwelt includes magnetoreception, vision, chemoreception, and hearing, ranked from most to least important. Magnetoreception enables turtles to detect Earth's magnetic field, 25,000 to 65,000 nanoteslas, guiding their long-distance migrations and allowing them to return to their natal beaches. Vision allows color perception and helps turtles recognize prey and predators. They detect light in the 400 to 600 nanometer range, roughly violet to green, though with less visual sharpness than humans. Chemoreception allows them to sense dissolved cues at very low concentrations, with lab tests showing detection in the micromolar range. This helps them to find food, recognize nesting areas, and possibly avoid predators. Hearing is the least developed of their senses, but still plays a role in detecting low-frequency sounds such as approaching predators, wave action, or underwater disturbances. Both hatchling and adults hear in the 500 to 1,000 Hz range, and juveniles up to roughly 1,600 Hz. Their best sensitivity is between 200 and 400 Hz. One key behavior tied to nesting is magnetotaxis. Adult turtles rely on the Earth's magnetic field to navigate across long distances and, most importantly, to locate their natal beaches where they return to lay their eggs.
A critical developmental window is the natal crawl, when hatchlings move from their nest to the ocean. During this time, they imprint on cues from their beach, especially magnetic information that they use years later when returning to their nest. Exposure to cadmium, a toxic metal, disrupts this system. It accumulates in tissues, damages cells, and impairs orientation by interfering with the nervous system. This can cause navigation errors, reduce reproductive success, and lower egg viability. This is connected to our experiment. Does preventing hatchlings from crawling impact their ability to use the magnetic field to remember their natal beach? Our hypothesis is that turtles denied the crawl will not imprint correctly and will show weaker orientation toward their natal magnetic signature as adults. To test this, hatchlings will be split into two groups, one allowed to crawl naturally and one prevented. Later, we would expose them to natural or altered magnetic fields and test their orientation in a circular water arena. Behaviors like directional swimming, searching, or hesitation would be recorded in an ethogram using video and blind observers. Altogether, the green sea turtle's sensory systems, behaviors, and critical windows show how complex its survival strategies are, and why protecting nesting beaches and ocean habitats is vital.